2.2 circles. Circle is our first conic section that we're going to cover, and we're going to look at the center radius form of an equation. A circle is going to have an equation that looks something like this: x minus h squared plus y minus k squared equals r squared. H and k are going to be numbers, and those are going to dictate the center. So that equation right there is going to be really important for us in this section. And it's going to have a center at h comma k. And we're going to see the radius of that circle is going to be r. So be careful there. I know the equation says r squared, but the radius is going to be just r. The general form is a little bit less useful for us. The general form looks similar: x squared plus y squared plus cx plus dy plus e equals 0. Center radius form is a lot more useful. It's nice when we can see the center and the radius of the circle. We can just do more stuff with it more easily. General form you'll see, but a lot of the times when you see general form, you have to convert it to center radius form. Example 1, find the center radius form of the equation of each circle described. Okay, so this is easy if you know that general or the center radius form up top. So the center is at 1 comma negative 2, so that means the formula is going to be x minus 1 squared plus y plus 2 squared. All right. So, y minus k, so it's minus negative 2 is why it's going to be plus. I'm going to fix that 2 right there. So we have x minus 1 squared plus y plus 2 squared equals, and then since the radius is 3, we're going to have to square that for the formula. 3 squared is 9. That's it. That's the center radius form. So then the other one, we still want the center radius form. You'd have x minus 0 squared, which of course that's just x squared, plus y minus 0 squared. Same thing, that's just y squared. And the radius is 2, so of course 2 squared is 4. So this equation is very important. This is a circle of radius 2 that's centered at the origin. This one over here is a little bit harder to see, but you've got a center at 1 comma negative 2 and a radius of 3. Example 2 says graph the equation. What you're going to want to do is find the center and the radius. So you look at the center and basically you're looking for what makes this 0, I guess. So that's 1, negative 2. So the center of this circle is going to be the point 1, negative 2 right there. Now you're going to look at a radius, and the radius is going to be 3 because 3 squared makes that 9 in the equation. So here's how I would graph this. Start at the center and go over in any direction 1, 2, 3 units. Oh, I missed. Let's try that again. And up 1, 2, 3, and over left 1, 2, 3, and 1, 2, 3. So you're going to have a circle that has to go through those points. Okay, as long as you draw a circle that goes through those points, you're going to have a circle of radius 3. So do your best. Let's try that again. That's really hard. Let's use the circle tool. Ah, there we go. That's perfect. So then this next one, again, you want to identify the center. In this case, x minus 0 and y minus 0. This is going to be a center at the origin, 0, 0. And the radius is going to be 2 because 2 squared is 4. So the radius is 2. So I'm going to go over 2 in any direction. You can't really go diagonal because it's hard to tell where 2 is diagonally. And then I'm going to draw a circle with the center at the origin. and go through those points. Recall completing the square. Back in algebra class, algebra 1, we learned how to fill in this blank here. X squared plus 10x plus blank. We want to complete the square, and the process was take this number right here, cut it in half as 5, and then square that number, and that's what goes in the blank. What we've just done is we've completed the square. If you think about factoring, x squared plus 10x plus 25 factors into x plus 5, x plus 5, or x plus 5 squared. There is your square. That's going to help us because that's part of the circle formula. So completing the square is going to be a big deal in this section. Now the next one is going to be a lot harder because of this 2 in the front. That complicates the issue quite a bit. And so what we want to do is factor out that 2. And so if you factor out that 2, you'd have 2 times x squared plus 6x plus blank. Okay. So now we can do the same thing with our expression inside the parentheses, where we look at the middle number. That middle number is 6, and we're going to take half that number is 3, and square that number back is 9. And so we've just completed that square. It says x plus 3 right there. So x plus 3 squared. But there's this 2 in the front of it, and that 2 really complicates the issue. In that blank is not going to go a 9 because you have to think about the distributive property. 2 outside times that 9 is going to be 18 is what goes in that blank. Okay? So I know that's kind of tough. That's kind of tricky. You're going to have to bear with me. You're going to have to figure that out. Show that the equation has a circle as its graph. Find the center and the radius. So in example 3 there, they're giving us the general form of the equation. We want to write it in center radius form. So what I would do is kind of split it up and put your x terms, x squared plus 4x plus blank, and then write your y terms, plus y squared minus 8y plus blank. All right, and we're going to do 2 different completing the square problems. So eventually you're going to need to add that 44 over to the other side. Just let's go ahead and do it now. Add the 44 over, so equals 44. So what we're going to do is we're going to complete the square twice. Look at this number right here in the middle. This 4, half of that is 2. Square that number is 4. So by filling in a 4 in that blank, we have completed the square. Unfortunately, we've also created this problem where we made a 4, we put a 4 into our equation that wasn't there. All right, that 4 is not really there in our equation, so you've got 2 different things that you can do. Either, since you added 4 to the left, you can add 4 to the right, or you can just come in and just immediately subtract 4. Either way. So let's just do it this way. Let's say we added 4 out of nowhere, so we subtract 4, and now it's no harm, no foul. Let's do the exact same thing with the y terms. See how there's a minus 8 right there in the middle? Half of that minus 8 is minus 4. If you square that number, you get 16. And so 16, positive 16, it's always going to be a positive when you square it, goes in that blank, and we have just completed the square. Y squared minus 8y plus 16 is y minus 4 squared. But again, the problem is we added 16 that kind of just came out of nowhere. So we're going to subtract 16 just to cancel it out. So it's like we didn't do anything. We added 4, subtract 4, we added 16, we subtracted 16. So your squares are coming in. Right here is x plus 2 squared, and right here is y minus 4 squared. But we've got those minus 4 and the minus 16, which put together that's minus 20, equal to your 44. So we want to make that look like center radius form. We're going to add the 20 over there. And now we have x plus 2 squared plus y minus 4 squared equals 64. That equation right there shows that we have a circle. This is center radius form. We can see that the center is at -2, comma 4, and the radius square root of 64 is 8. Okay, let's shrink this down so we can get to example 4 and have a little bit more room. Example 4 is a little bit harder. Problem 4, show this equation as a circle. Again, I'm going to complete the square. So let's start by subtracting this 41 over. It's not the only way you can do it, but that's the way I like to do it. I'm also going to kind of arrange my like terms, or my common variables, I guess, not like terms. So I put an x squared plus 12x, leave some space for you're completing the square. And then we have plus y squared minus 10y, leave some space. And then we've got our equals negative 41. We're in pretty good shape for completing the square right here. We're going to have to do it twice. So we check out this middle term right here, 12, and the process says take half of that number is 6, and then square that number is 36. That completes the square. X squared plus 12x plus 36 is x plus 6 squared. Now, a couple of ways to do it. I'd like to think of it this way. If you added 36 to the left, you could add 36 to the right, or you add 36 to the left, so take away 36 to balance it out. Either way you want to go is the same thing. I'm going to do it this way. Add 36 to both sides. So then we look at the y's, and we look at this middle term. Half that's minus 5. Square that is 25. So we've completed the square. We have y minus 5 squared, but we also added 25 out of nowhere. So I'm going to go ahead and add 25 to the other side just to keep it balanced. So what do we have? Negative 41 plus 36 plus 25 is going to be 20. And so now we've got our equation in standard form. But we want to know the center and the radius. Okay, so this is the equation of a circle. But the center is going to come from these two, of course. We've got the center at negative 6, 5. And then the radius is going to come from this number 20 over here. So what we're going to have to do with that is think about it as something squared. R squared equals 20. So we're going to end up needing to take the square root of 20. The radius is the square root of 20, but normally we'll simplify that, clean that up. Square root of 4, square root of 5, that's 2 times the square root of 5. So we would say the radius of this circle is 2 times the square root of 5. There we go. There are 3 possibilities for what could happen with this equation. If r is greater than 0, that's what we see the vast majority of the time. Okay, r stands for radius, and if you've got a radius that's greater than 0, we're talking about a circle. That's what this section is about. And so you see what appears to be the equation of a circle. But if r equals 0, imagine what you would have if you had a circle of radius 0. You'd have a center, and then radius 0, well, that's just a point. So if r equals 0, we would be talking about a point, not a circle. And then the third possibility, if r was a negative, if r was less than 0, imagine trying to draw a circle with a radius that's negative. That doesn't really make sense. And so we would say the graph is undefined or non-existent. Doesn't exist. Example 5 says the graph of an equation is either a point or non-existent. Which is it? So you can't just look at this and tell. you're going to have to put it into center radius form. So we do that completing the square business that we did a minute ago. X squared minus 6x plus blank plus y squared plus 2y plus blank equals negative 12. So half of this number right here is negative 3. Square that is 9. So we've just completed the square for that part, x minus 3 squared. Over here you see a 2, so half of that number is a 1. Square that is a 1, and we've completed the square over here. But what we've done is we've thrown off the equation by adding this 9 and adding this 1. And so what we want to do is we want to subtract a 9 and subtract a 1 just to keep my equation in balance, just to keep everything equal. So we've thrown off the equation by minus 10, but then we fixed it. Okay, we threw it off by positive 10 and we fixed it by subtracting 10. So then if we want to make it look like our regular form, let's add the 10 over, and we get x minus 3 squared plus y plus 1 squared equals negative 2. And this number right here is the key. That would give us a negative r value, and if that r value is less than 0, the graph is undefined. Okay, we're going to have a radius that's less than 0. Nope, that's not going to work. So this is non-existent.